Hello everybody, welcome to the big video. We're actually going to start building a little game here. At this point you should have already talked a little bit about two-dimensional arrays. So what we're going to do is, if you haven't noticed already, we're going to build a little game using two-dimensional arrays. Most people have probably played Tic-Tac-Toe. If you are unfamiliar, I'm sorry. You are alive, right? But basically how it works is X and O. There's just X and O's. Now I've got a basic array kind of written out here. Now you could do this with a one-dimensional array if you wanted to. Like I could come down here and what I would need basically is 9 slots. Probably be more efficient if I just did it this way. Boop. Oh, now it's probably just, let's go down here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that. So you could do this with 9, and that would be 0, and this would be 8. The only difference is how I would write it. I could just print 0, 1, 2 across the top, 3, 4, 5 in the middle, and then this on the next line, and it would basically be the same as a two-dimensional array. So there are a couple of different ways to write this. Both have advantages and disadvantages. This is actually somewhat easier in one particular sense, whereas this is easier in another. It just, like I said, depends on how you're writing it. Like when I'm trying to put stuff in, this is actually a little bit easier. When I'm trying to put stuff in, this is a little bit more difficult. But as far as just, this is already a two-dimensional array, it's already set up like a tic-tac-toe board. So this is a little easier to understand in that regard too. So I've written a little map here. This is the map of my board. Now, the first thing to ask is what type of array do we need? We have X's and we have O's. So what type of data is that? What is an X and an O? Well, it could be a string, depending on how I want to do this. That was supposed to move. There we go. It could be a character. Depends on how you want to do this. Either one would be technically correct. I'm just going to go ahead and just use character. So I'm going to make a character array. And how big do you think that character array is going to have to be? Well, it'll be a 3 by 3. So 1, 2, 3. 1, 2, 3. So I just make a character array just like this. Now, a character is an apostrophe. And then whatever goes inside that is a character. So what we're going to do is we're going to build this. Now, to build this, we need a couple of things. First off, we need our board. Second, zoom in here a little bit. We need to be able to display the board. Once we've displayed the board, well, we got to be able to interact with it. So what I want to do is basically fill it with just X's. I'm not worried about swapping players back and forth or anything like that. I just want to fill the entire board up, and then it ends. So I also have to know how many turns does a tic-tac-toe game go? Well, almost every tic-tac-toe game, if you're paying any attention, it's a tie. It goes the full duration. But how many turns do we have? Well, how many blocks do we have? We have 9, so we have 9 turns. Basically, I just need to go until someone's either won or the turn counts maxed out, basically. So I need to know what turn it is. A variable needs to be for that. I also need to know, let's see, players, right? We're going to start with player X. Now, I'm going to build this, and I'm going to build this in the longest possible way. And the reason I'm doing that is it is much easier to understand if you do things slightly longer, especially in programming. This program can be built in, oh geez, definitely less than 100 lines. But the way we're going to build it is going to be a lot longer. I'm going to do most things the long route. I'm not going to take any shortcuts for the most part, which means it'll probably be somewhere around 200 to 300 lines by the time we finish it. And you may ask, well, why wouldn't you just do it the shorter way? Because the shorter way is more complex. It's a lot harder for people to understand. So the way I usually tell people to do things when they're building a program is, number one, make it work. That's your first goal. It's got to work, before you worry about anything else. Number two, maybe start looking for ways to make it more efficient. Places where you can save time. Anytime you're dealing with arrays, a couple of loops here and there, and you can save yourself hundreds of lines of code. Because an array is inherently built for you to use loops to cycle through it and stuff. So there's a number of ways you can cut lines and basically do the exact same thing. Most people would probably prefer to do, 100 lines of code as opposed to 500, but only if you understand it. If you attempt to do the 100 and you have no idea how to do it that way, you're just going to end up shooting yourself in the foot and it's not going to get finished. So the first goal is to just make it work, and the long way is the easiest to understand. So we're going to build it the long way. So first off, I need a board. So I could make this a regular variable that I'm going to have to pass up to all my different methods. I'm going to opt not to do that. I'm going to make it a global variable. So in this case, public static character board. Two-dimensional. And I can go ahead and new character 3 by 3. Make it certain size. Now it doesn't have anything in it right now, so let's see, players, fill the board with X's. Once I can do that, swap player. Once I can do that, which means fill the board with X's and O's, I see who won. And once that's done, well, that's the end of the game, pretty much. Maybe I could ask to play again and reset everything. But here we go. First off, I got my board set up. All right, that's there. Now, it's not set up yet. Our board, the way it looks, if I printed it, it's just going to be some empty slots. Now, if I could point and click using a GUI, then this would be relatively fine. I could just click here and an X goes there. Boom, like that. I click over here, then an O goes there. That's not that hard, and if you wanted to play with some GUI stuff, you can. But since we're doing command line stuff, just stuff on our output window, I can't click and interact with it. So what I'm going to do is I'm going to use numbers to represent what slot is what. 2, 3, 4, 5, 6, 7, 8. So what I'm going to do is I'm going to ask the user to pick one of these numbers that are going to be displayed. If they pick 0, their X or O will go there. If they pick 4, their X or O will go there and replace it. So I need to fill this board with these numbers first. So simple way to do that, I could make a method. I could just do it at the start of the main. I'm just going to make a method called initBoard or something like that. Public static void initBoard. And all I got to do is just, say board 0, 0 equals this. Board 0, 0 equals 0. And I could use 1 if you prefer. It doesn't really matter. 1, 2, 3, 4, 5, 6, 7, 8. And I can just kind of copy and paste. This is just going to set up the board with what I want here. So 1, 1. 1, 2, 2. And there is a faster way, as I've mentioned before, but I'm not going to do those ways. I'm kind of leave it up to you guys to try and think outside the box here. How could I do this better? Of course, I'll be happy to show you when it's time. When I do the big projects at the end of the chapters, I will be happy to show you the fastest possible way I could do that. And there might even still be some things I can cut off, but that maybe I missed. There we go. 6, 7, 8. And this will just put those numbers in there, and I can replace them with my X's and O's when I'm ready. This is going to be a relatively lengthy and complex program, so hopefully you're following along, building along as well. If all you're going to do is watch this, you're going to have some trouble, particularly for our big 30-point project we'll have later. So initiating the board, just setting it up. And there is a possible way you can use a for loop to basically do this same thing. Although it would be easier with a string than it would with a character. But so I need to print my board. So I'm going to make a public static void display. I'm going to say display board. It's fine. Display board. It should be named something that it's going to do. That way it's pretty obvious just by looking at it what it should be doing. So all I'm going to do here is just simply print box plus, in this case, board 0, 0 plus another box plus, let's put a closing box there, board 0, 1 plus closing box, open box, plus board 0, 2 plus closing box. So this is just going to be my box. It'll have a 0, 1, 2 in it. And I'm just going to copy and paste that. As you can see, copy and paste. There's always a pattern somewhere where you can actually save yourself some room. Now our board's relatively small, so no matter what we do, we're really not going to save that much room at the moment. But if we had a much larger board, then there would be a much easier way to do this than the way I've done it here. So let's take a look. For some odd reason, my little dude guy is not sticking around. There we go. Now you'll stay. There we go. 0, 1, 2, 3, 4, 5, 6, 7, 8. My board is displayed. So fairly quick and easy. I've got my board set up, and I can hide that if I need to. I've got my display. So the next on my list, and whenever you're writing any kind of program, I find that one, if it's got an array like this, make a map. That's always exceptionally useful to have a little map to draw back on, where these locations are and stuff. 2, make a little list of things you've got to do, perhaps in the order you need to do them. So I need to know, what turn it is. So for that, let's make a variable, public static int turn. And of course it starts out as turn 1, right? I need a for loop for this. Obviously I can't just put in 1x and have the game end. Well, not a for loop, a while loop. Because my game could end before the for loop ends. This is one of those situations where I will have people throw up a for loop and you don't need it to be a for loop. Now, you can use a for loop and close it out manually, but a while loop is designed to end. That's how you write it. It ends when whenever the program is over with, whenever the conditions are met. A for loop is designed to go a certain number of turns. The problem with saying for loop go 9 turns, what if I win in 6? The for loop will inherently try to continue going. And that's not something I want to do. So, now, I probably want to go ahead and just have a tic-tac-toe or some sort of public static static void. Let's call this game. And this is where my game's actually going to be. And I'm just going to come down here and run game. Game. There we go. So my whole tic-tac-toe everything will be here. I know display board works, so I can just kind of erase that for right now. There we go. And in this video, we'll get about halfway through this project. We'll finish the rest of it later. We're going to at least try to get to where we fill the board with X's before we stop out. And then the next video will be swapping players and seeing who won. Those will be the last little bits we have to do. So, first and foremost, I need a loop that goes until I've won, right? So, while turn is less than 9. Let's just say we're not checking wins yet, so I'm just going to say while turn is less than 9. Or I should say less than 10. And wow. Now, I'm going to have to add later, and, while turn is less than 10, or I should say, and I haven't won, and game not over. Maybe I'll make a Boolean variable, game over, and that'll end this loop and cause it to finish. There's a couple different ways to do this. I could force everything to close with system.exit. Some ways are nicer than others, but better programming practices than others. Well, first things first, I need to display the board. I need to ask the user, please enter your X, because it's just going to be an X. I need a scanner for all this. So I'm going to go ahead and set that up. And I can set this up here if I want, but I'm really only going to be using it in this, so it doesn't really have to be a global variable. Input equals new scanner system.in. I'll import it. And if you don't have the button that automatically does that, that means you misspelled it, or maybe you're using a different program, but it's basically import javautil.scanner. And if you happen to see the word package, blah, 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 this import has to go underneath that. Package always goes to the top. So with my scanner set up, I can ask. Now I've got this board of 0 through 8, right? And that's where I'm going to ask them to type in a number, 0 through 8. Now I can take this as a string, or I can just take it straight as an int, depending on what I want to do with this. I'm going to go ahead and just take it as an int and assume the people aren't morons. It would be safer to take it as a string, though. Or even maybe a character, but the string would be the safest. Well, anyway, let's go ahead, int. I guess I'll call this move equals input.next int. All right, so now I need to place my piece in the board, right? I can put all this here, or I can just make a method for it. We're definitely not getting away from methods, as you can see. So public static void. Now, I'm going to make this a Boolean. And we'll call this check move, maybe? Check move. And I have to pass it int m, the move I want to make. And the reason I'm making this a Boolean is when I run this, I want to know if I made a move or not for later. I don't want it to just do its thing, because I need to know when I need to swap players. So I have to kind of plan this out ahead of time. I can always just put my X in there, but if I don't know if it actually worked or not, I could make another variable and just leave this, void, and then change that variable, use that as a check. But this returning is probably the easiest way to do it. So, all right, so I've got 8 possibilities here. So 1 through 8. So the first thing I need to do is if m is not within that range, so if it is less than 1, and it's a 1, not an L, and m is Problem with these long videos, my headset turns off. Let's see here. Greater than 8. So if it is less than 1, that's not allowed. That's a 0. If it's greater than 8, that's not allowed either. Now, of course, if I type in Bob, this is going to crash. I could put in some checks for that, but else. So that's not a choice. Return false. End if. Now, of course, you're going to see it's red because I have to return in here too. Now, if it's within range, so if it's within range, I have to check and see which number was picked. So if m is equal to 1, then what does that mean? Well, I'm trying to put it in the first slot. So I have to know if I can do that first. And there's a couple of ways to do this. The first way, my board already has a 0 in it in this case. Well, actually, I need to start with 0. Let's fix that. So if it is less than 0, we wouldn't be able to put anything in the first slot. There we go. So if it is 0, that means I go in the first slot. But I have to check and make sure that it's empty first. And for it to be empty, it has to have a 0 in it, because that's what I set it to have. So I could do this as a nested if. If board 0, 0 is equal to 0, like that, then it's empty, right? I could also do a compound if up here with that, where I said if m equals 0 and this equals 0. It just depends on how you want to write it. But the big issue here is the reason I'm not doing the compound if is because I'm going to have another if anyway, either way. So because 1 means I can put something in it and 1 means I can't. So in this case, I need to place my x. So board 0, 0 equals x, like so. Now I probably also, for now, want to know what player is being played. So let me go ahead and add this. If player equals x. I'm going to use capital. Let's go ahead and do it this way. This might be a little shorter, but and player equals x. Now I'm going to make a player variable up here, and the reason I'm doing this, public static character player, and I'll just make him x. The reason I'm doing that is so I know which player which player is going currently, and we can swap that left and right later. Like when I go, I would swap it to O. We'll worry about that later. Already occupied. Try again. So I would return true here. And I'd return false, obviously, here. So we have our first if it's within the range. Otherwise, that's not a choice. Our second if basically says if it's x's turn and I choose 0, if it's empty, if it's not empty. Just like that. Now for what we're doing, we're just worried about x. So what I'm going to do is I've got this here, and it's going to be a lot of copy and paste. Now again, there is a much more efficient way to do this. Way more efficient, but I am going to do it the long way. So else if I choose 1. And then I'm going to come down here and make a couple of small tweaks. There's 1. I just added the 1 to it. And this is where that little map comes into play. 0, 1. 0, 2. And I just go down the list, basically. Now this is where copy and paste can save your life, or end it. If I accidentally copy an extra brace, come down here and paste, now I've got all kinds of red lines. If that happens, Control Z. Undo whatever it is you just broke. And try it again. So I'm going to copy that else if. I'm going to paste. That'll be 2, 2, 2, and 2. And I'm going to do this again. 4, 3. Now 3 is a little different. In fact, that's going to be a 1. That'll be a 0. That'll be a 3. And feel free to pause if I'm going too fast. I'm trying not to make this thing be an hour long. And this is just the first half, so 4. That'll be 1, 1, and 4. We'll do it again for 5, 6, 7, 8. This is where some logic errors can creep in. You forget to change one of these numbers, and all of a sudden, whenever you try to fill something out, what ends up happening is it goes in the wrong place, or it doesn't go where it's supposed to go. So you got to be very careful when you're doing this that all the numbers are as they're supposed to be. So 6, and that'll be 3, 0. Actually, I'm sorry, 2, 0, and 2, 0. Those have to match. And that'll be 6. And we'll do the same thing, and we're almost there. That'll be 7, and that'll be 7. That'll be 1, 1. And at this point, I know it's between, 1 and 8, 0 and 8. Boop. So I don't really have to change this to 8 like this. I could just say else, but I'm going to go ahead and write it out anyway for the moment. All right, so there we go. Return false, return true, all that good stuff. I don't know. Would it be better if I just make this an else? There's no other possibility. That's when you want to have an else. So if it's 0 and player is X, if it's 1, 2, 3, 4, 5, 6, 7, 8, well, there is another possibility actually if we were swapping players and whatnot, but I'm just going to go ahead and leave it as it is. We'll go ahead and add an else. Return false. And I'll just say something's not valid for now. I'll just go ahead and add that in there. So from start to finish, I just did a bunch of copying and pasting, as you can see. And it probably would have been better if I had done the first one and then checked to make sure that worked. The second one, checked and made sure that worked. Third, fourth, fifth. It takes a little more time, but here's the problem. I started at line 39 and is finished basically 100 lines later. If I screwed up any one of these things, pretty much that means all of them are screwed up and you're going to have to fix them all. It takes far less time to check them individually than it does to have to, fix every single one of them because you just kept copying and pasting and screwing it up. I've done this enough to where I'm not that concerned about it. I'm pretty sure this should work. But new programmers will tend to get a little overconfident and just start pasting pop, 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 pop without checking anything. Try to avoid that if you can. Now if I did this right, my end boolean shouldn't be red. And that's because I have this else here. Something's not valid, and it's never going to go to that right now because, well, we're just filling the X's. So for right now, that'll never happen. I'm either going to pick the right number. If I don't pick the right number, it's not even going to go to that. If I pick 0 through 8, then, oh wait, actually, if m is greater than 8, no, less than 0. Yep, that's right. So it won't even come here unless I'm within 0 and 8. So it's just not possible to be here. Unless my player changed to O suddenly, then it would go there. So let's take a little look, move, and I'm just going to say, I called this, I believe, I'm just check move. So check move. And we're going to say, I'm going to give it that value. Now I probably want to Boolean check equals. This is going to be true or false. And I'm not going to do anything with this just yet. But later, I would want to check if the move was valid so I can swap the players. So for now, let's test. If I fill this entire board out, it should work. Now I'm going to print a little display board at the end. Because the way this works is it's going to go until the full turn is done, but it only prints at the beginning. So once I make the last move, it's just going to go here. And I'm just going to say, you are tied for that. The only time I'll ever leave this loop is if I've tied. So I need to swap players and check for wins. That's all that's left here. So let's run the game and give it a check and see if it does what I want it to do. So if I choose 0, oh, that's not a choice. 1, 2, 3. Ah, so we got us a problem. So I gloated earlier about how I'm pretty sure that there's no problem. And then there's a problem. So it basically goes to show you no matter how good you are, you're going to screw up at some point. But let's go see what my problem is. It says that's not a choice. Okay. That's an easier thing to figure out than most things. So check move, let's see. So if m, the thing I passed, is, oh, whoops, I did it backwards, that's why. If it's greater than or equal to 0, if it's less than or equal to 8. So yeah, I was looking for the specific numbers that wouldn't work. So that's where I screwed up. Fortunately, it was here, and that's the only thing I have to change. If I screwed up here, then I would have to change every single one of these if statements here. So the change was from less than to greater than or equal to, from greater than to less than or equal to. And that should fix my issue. Let's find out. 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's still going. 8, 9, 1, 2, 3, 4, 5, 54, 37. Oh, well, it's going. Why do you think it's going forever? Because I forgot to do one little thing. And that is, it goes until the turn count reaches 9, right? But currently, there isn't a single place where I'm upping the turn count. Now, there's a couple of places I could put it. Obviously, when I make a move, turn plus plus. That's the obvious place. But the major issue there is I'm going to have to go down and do it to each one of these, which isn't a big deal. It has to be under the assignment here. But it's going to add a bunch of extra lines. Now there's another place I could do this, and that's in the method, the game method, rather. I do have a little thing here that is checking to see if I made a move or not. I could use that and just do it in one place, save myself some space. But again, I'm trying to, not trying to take the shortcut here. I'm going the longest possible route. So I make a turn every time I make a change to the board. If I didn't make a change, then the turn count doesn't go up. So let's see. We'll run it again. 0. I'll try it again. 0. Already occupied. 1, 2, 3, 4, 5, 5, 5, 5, 5, 5, 5, 5, 5. Still working good. 6, 7, and 8. You are tied. There we go. First step achieved. I have filled the entire board. with x's. Now, we're going to stop here, but in the next video, what we've got left is swapping players. So if I make a move, I'm going to swap players from x's to o's. And then I have to come up here and add more to my check move, because guess what? We're only checking for x's right now. I have to add a whole nother set of this for o's. Basically copy and paste, and I'm checking for O. But it's a lot of extra copy and paste and a couple of changes here. O's to those. Basically, all my X's become O's in the extra pasted ifs. And that's an extra 100 lines that gets added to the program. That's already about 200. You can kind of see where this is going. It'll be about 400-ish, probably, by the time we finish. Now, once we add that, we'll be able to put X and then O, X and then O until basically it fills the board. Once we've got that stage done, we can check for the wins. And just so you know, a win is 3 in a row. So effectively, if I get 3 in this spot, 3 in that spot, diagonals. So the real trick here is how many win conditions are there? 1, 2, 3, 4, 5, 6, 7, and 8 win conditions is probably what you're thinking. But there are 8 win conditions for both X and O, for a grand total of 16 win conditions. Which means I have to make 16 ifs that check every win condition. Now again, I could do this faster with some loops and a couple of other little shortcuts, but I'm not going to take it the slow route. I'm going to show you the long route because it's just easier to understand. If you want to try shrinking it down, that'd be a good challenge. Try seeing places you can cut up a little bit, because this program can be every bit of 100 lines of code if you want it to be, if you know some of the tricks to it. But if this 0, 0 has an x, and this 0, 1 has an x, and this 0, 2 has an x, well, x1. And I would do the same for every single possibility for x, and then every single possibility for O. And there you go. That would be the game. That's what we got left to do. And what we have left to do is mostly copying and pasting, honestly. The next video will be a little shorter. But there you go. If you have any questions or problems, you can ask me. If you need me to, well, you can pause, but I'll go through this video one more time from top to bottom. This is the end result video. And feel free to pause, check your code, and make sure it's working if it's getting anything weird. And there we go. We'll add our next 2 parts in the next video, and I'll see you then.